Hi, in this video we'll be going through the 8-step methodology of econometrics from Gujarati and Porter's Basic Econometrics textbook. Now this is a very general framework proposed by Gujarati and textbook. They call it the classical methodology of econometrics. It's not the case that all econometricians apply this strictly, and it's not meant to be prescriptive, but it's a very good framework for thinking about how good econometrics gets done. So the 8 steps are mentioned on this slide. They include stating a theory or hypothesis. That's usually the first step. Second step involves expressing that hypothesis or theory in a mathematical model. The next step is to transform that mathematical model into a statistical or econometric model that can be applied to data. Step 4 involves obtaining the data, and then in step 5 you use the data and the model to estimate parameters of the econometric model. Step 6 involves doing hypothesis testing on the estimated parameters, and once you're happy with the parameters estimated, you can use the model for forecasting purposes, or as in step 8, for informing policy proposals. Now let's apply this 8-step methodology to a specific example. The example we're going to look at is the consumption function, which is a model of consumption that you learn in your introductory macroeconomics course. Now there was a particular claim that was made when that model was introduced, which was that the marginal propensity to consume, the MPC of the model, is greater than 0 but less than 1. So that's a very clear hypothesis that is being stated, a very specific claim that's being made. The next step involves specifying the theory in a mathematical form. In mathematical notation, the simplest way to specify a function is as follows: y equals f of x. This is what you would have seen in high school. And that is exactly what is being done in this first equation on this slide. Here the statement is that consumption is some function of income. The next equation expresses this in a particular specification. It says that consumption equals some parameter beta 1 plus another parameter beta 2 times income. And you'll recognize the specification, the form of the specification, as a linear function, much like y equals mx plus c. Only difference here being that consumption is y, c is beta 1, the slope parameter m is beta 2, and the independent variable x is income. So now we have our mathematical model of the theory, and of course with the condition that beta 2, the slope parameter, lies between 0 and 1. Now this model tells us that there is an exact relationship between consumption and income. That relationship is linear. Now we know that it's not always the case that we can express exact relationships between economic variables. So we need to introduce some uncertainty into this model. In step 3, that's exactly what we do. In the first equation on this slide, we have consumption. I'll just label these equations to make it easier to refer to. I'll call this equation 1, and this one equation 2. So equation 1 takes our mathematical model and adds a u at the end, another variable. This variable is called the error term. And you can think of the error term as representing factors that affect consumption but are not taken into account explicitly. In other words, all the things that can influence the value of consumption in the economy other than income that is not explicitly added into the model. Equation 2 introduces some notation which you should be aware of. Notice above consumption, beta 1 and beta 2, there's a hat. This equation represents the estimated model. So equation 1 is the econometric model. Equation 2 represents the model that has been estimated. So whenever you see a hat like that, or like that, above a given variable, you know that that variable is an estimated value. Okay. So now that we have specified our econometric model, we need to obtain some data to plug into the model. In this case, we will be looking at time series data. So we'll gather data on income, aggregate income, as well as data on aggregate consumption for the South African economy. And in the example that I'll be showing you, the data range from around 1960 to about 2016. This graph plots the various values of those data. So consumption is expressed on the vertical axis and ranges from from 0 to 2 trillion. Income is expressed on the horizontal axis and ranges in value from 0 to 3.5 trillion rands. And these values are expressed in real terms. Now we move on to step 5, estimation of the econometric model. So this involves fitting a linear line to the data we saw on the graph of the previous slide. Now, how do we do that? We use a methodology or a technique called ordinary least squares estimation. And this is what you'll be learning in this course. Once we apply that method, we obtain the estimated values of the intercept parameter and the slope parameter. And what do we see? Well, our initial hypothesis that beta 2 lies between 0 and 1 seems to be confirmed by this model because we obtain a value of 0.63. Now, how do we interpret these two numbers? Well, let's start with the slope value of 0.63. What this tells us is that for a 1 rand increase in income, we can expect to see a 63-cent increase in consumption on average. With respect to the intercept parameter, the interpretation doesn't really make any economic sense. You'll see a negative value there of minus 0.125. And what that tells us is that when income is 0, we can expect to see aggregate consumption of minus 125 billion. So remember, these values are expressed in trillions. This slide shows us the model graphed, juxtaposed with the actual data. Here you can see that while the data never goes into negative territory, if we extend the line fitted by our model, it will eventually go into minus territory over here, hence the negative slope intercept parameter. Now that we've obtained our two parameter estimates, we can conduct some hypothesis testing. Things we might be interested in testing in this instance is whether the relationship between income and consumption is indeed statistically significant. We might also want to test whether the slope parameter is statistically different from 1 or not. Once we've completed our hypothesis testing, we can then use the model for forecasting purposes. In this instance, we might be interested in what level of aggregate consumption we can expect for an aggregate income value of 5 trillion rand, in which case we simply plug in the number 5 into this equation. As follows. And then you can solve for C and obtain an predicted value of consumption for 2020. You can also use the model. We can also use the model for policy purposes. In this example, government wants to raise consumption expenditure to 2 trillion rand in order to increase employment levels. So it would then need to know what level of income is consistent with consumption expenditure of 2 trillion. In this case, you plug the value 2 into the left side of the equation and then solve for income. Once you've done that, you should obtain a value of 3.3. So you would need 3.3 trillion in GDP to achieve 2 trillion rands in aggregate consumption. And that ends the 8-step methodology of econometrics. Looking forward to what you can expect for the rest of the semester. Next week, we'll be covering Chapter 1, talking about the nature of regression. And for the 4 to 5 weeks following that, we'll be engaged with Appendix A, which is a review of basic statistics. Appendix C is no longer part of the curriculum, so you can ignore that. And then towards the end of the first term and throughout the second term, we'll be engaged in chapters 2 to 6 of the textbook. The rest of the textbook is then covered in your third year. And that's all. Thank you.